Secondary, welcome to our math program. Today we have calculus. Our lesson today is the derivative of trigonometric functions. What is the derivative of the trigonometric functions? First, we have a very important theorem. If y equal sine x, then the first derivative of the function y equals cosine x. And if y equals cosine x, then dy dx equals negative sine x. And if y equals tan x, then dy dx equals sec to the power 2x. Then the derivative of sine x equals cosine x. The derivative of cosine x equals negative sine x. The derivative of tan x equals sec to the power 2x. What about the derivative of cotan x? The derivative of cotan x equals negative cosec to the power 2x. And the derivative of sec x equals sec x multiply tan x. And the derivative of cosec x equals negative cosec x times cotan x. Then the derivative of cotan x equals negative cosec to the power 2x. The derivative of sec x equals sec x multiply tan x. And the derivative of cosec x equals negative cosec x multiply cotan x. If y equals sine ax, then dy dx equals a cosine ax. The derivative of sine ax equals cosine ax. And the derivative of the angle ax equals a. Then the derivative of sine ax equals a multiply cosine ax. The second rule, if y equals cosine ax, then dy dx equals the derivative of cosine x equals negative sine ax. And the derivative of the angle ax equals a. Then the derivative of cosine ax equals negative a multiply sine ax. If y equals tan ax, then the derivative of tan ax equals a, which is the derivative of the angle ax, multiply sec to the power 2ax, which is the derivative of tan ax. If y equals cotan ax, then dy dx equals the derivative of cotan ax is negative cosec to the power 2ax. And the derivative of the angle ax equals a, then the derivative of cotan ax equals negative a cosec to the power 2ax. If y equal sec ax, then dy dx equals the derivative of the function sec ax equals sec ax multiply tan ax. And the derivative of the function of the angle ax equals a. Then the derivative of the function sec ax equals a multiply sec ax times tan ax. The last rule, if y equal cosec ax, then dy dx equals negative a multiply cosec ax multiply cotan ax. The derivative of cosec ax equals negative cosec ax multiply cotan ax. And the derivative of the angle ax equals a. Also, if y equals sine ax plus b, now we have a complex angle ax plus b, then the derivative of y with respect to x dy dx equals derivative of sine ax plus b equals cosine ax plus b multiply the derivative of the angle, derivative of ax plus b equals a. Then the derivative of sine ax plus b equals a multiply cosine ax plus b. And if y equal cosine ax plus b, then dy dx equals, yes, negative a multiply sine ax. And if y equal tan ax plus b, then dy dx equals derivative of tan ax plus b equals sec to the power 2 ax plus b, and the derivative of the angle ax plus b equals a. What about y equals cotan ax plus b? dy dx equals, the first derivative of cotan ax plus b equals negative cosec to the power 2 ax plus b, and the derivative of the angle ax plus b equals a. Now y equals sec ax plus b, dy dx equals derivative of sec ax plus b is sec ax plus b multiply tan ax plus b multiply the derivative of the angle ax plus b, which equals a. The last rule, if y equal cosec ax plus b, then dy dx equals negative a cosec ax plus b multiply cotan ax plus b. Let's start with the first example. If y equals 3 sine x minus 2 cosine x plus 9 tan x, find dy dx. We have trigonometric functions. Y equals 3 sine x minus 2 cosine x plus 9 tan x. dy dx equals 3 multiply 3 is a coefficient, multiply the derivative of sine x, which equals cosine x, minus 2, the coefficient, multiply derivative of cosine x, which is negative sine x between two brackets, plus 9, multiply the derivative of tan x, which equals sec to the power 2x. Then dy dx equal 3 cosine x plus 2 sine x plus 9 sec to the power 2x. Now we move to the next example. If y equal x power 2 times cotan 3x, find dy dx. This function y equal x to the power 2 multiply cotan 3x is product of two functions. The first function is x to the power 2, and the second function is cotan 3x. Now we have derivative of product of two functions. Then dy dx equals the derivative of the first function, the derivative of x power 2, which is 2x, multiply the second function cotan 3x plus the first function x to the power 2 multiply the derivative of the second function multiply the derivative of cotan 3x, which equals negative 3 cosec power 2 3x. Derivative of cotan 3x equals negative cosec to the power 2 3x, and the derivative of 3x equals 3, then the derivative of cotan 3x equals negative 3 cosec to the power 2 3x. Then we can write dy dx as 2x multiply cotan 3x minus 3x to the power 2 cosec to the power 2 3x. Now we move to the next example. If y equals cosec x multiply cotan 2x, find dy dx. Here the function y equals product of two functions. two trigonometric functions. Cosec x multiply cotan 2x. Then the first derivative dy dx equals the derivative of the first derivative of cosec x, which equals negative cosec x cotan x multiply the second function, which equals cotan 2x, plus the first cosec x multiply the derivative of the second function, derivative of cotan 2x, which equals negative 2 cosec to the power 2 2x. Then dy dx equals negative cosec x cotan x multiply cotan 2x minus 2 cosec x multiply cosec to the power 2 2x. Now another example. If y equals cotan x over x, find dy dx. The function y equals quotient of two differentiable functions. Y equals cotan x over x. Now, what is the derivative of the quotient of two functions? Yes, dy dx equals the derivative of cotan x, which equals negative cosec to the power 2x, multiply x minus the derivative of x, which equals 1, multiply cotan x all over x to the power 2. In the simplest form, dy dx equals negative x cosec to the power 2x minus cotan x over x to the power 2. Another example. If y equals, between two brackets, 1 plus cotan x all to the power 3, find dy dx. Now we have bracket to the power 3. Y equals, between two bracket, 1 plus cotan x all to the power 3. Then dy dx equals the derivative of the bracket multiply the derivative of the function inside the bracket. The derivative of the bracket, 3 multiply 1 plus cotan x all to the power 2. 3 multiply the bracket all to the power 2, multiply the derivative of the function inside the bracket. Derivative of 1 equals 0, and the derivative of cotan x equals negative cosec to the power 2x. In the simplest form, dy dx equals negative 3 cosec to the power 2x multiply between two bracket 1 plus cotan x all to the power 2. Another example. If y equal cosec to the power 2 1 plus 3x to the power 2, find dy dx. Now we have y equal cosec power 2 1 plus 3x power 2. Here the angle is a complex angle, and y equal cosec to the power 2 1 plus 3x power 2. Now we can write y equals cosec 1 plus 3x power 2 all to the power 2. Now we have a bracket to the power 2. The derivative of the bracket dy dx equals 2 multiply the bracket power 1 cosec 1 plus 3x power 2 all to the power 1. Multiply what? Multiply the derivative of the function inside the bracket. The function inside the bracket is a trigonometric function, which is cosec 1 plus 3x power 2. The derivative of cosec 1 plus 3x power 2 is negative cosec 1 plus 3x power 2 multiply cotan 1 plus 3x power 2 multiply the derivative of the angle. The derivative of 1 plus 3x power 2. Derivative of 1 equals 0, and the derivative of 3x power 2 equals 6x. Then the derivative of the angle is 6x. Then dy dx equals 2 multiply the bracket cosec 1 plus 3x power 2 multiply negative cosec 1 plus 3x power 2 cotan 1 plus 3x power 2 multiply 6x, and we can write dy dx in the simplest form. dy dx equals negative 12 multiply cosec multiply cosec, which is cosec power 2 1 plus 3x power 2 multiply cotan 1 plus 3x to the power 2. Another example. If y equals square root of x plus sec x, find dy dx. Now we have a square root. Y equals square root of x plus sec x. Then the first derivative dy dx equals 1, the derivative of x plus sec x tan x, which is the derivative of sec x. Then in the numerator, we can find the first derivative of the function inside the root, the square root. Derivative of x equals 1 plus the derivative of sec x equals sec x tan x. All over 2 multiply square root x plus sec x. Then the derivative of square root x plus sec x equals 1 plus sec x tan x over 2 multiply square root of x plus sec x. Another example. If y equal sine 3x minus 5 cosine 2x plus tan half x, find dy dx. We have a trigonometric functions. Y equal sine 3x minus 5 cosine 2x plus tan half x. Then dy dx equals, what is the derivative of sine 3x? The derivative of sine 3x is 3 cosine 3x. Cosine 3x is the derivative of the function sine 3x, and 3 is the derivative of the angle 3x. Minus 5 is a coefficient, minus the coefficient 5, multiply the derivative of cosine 2x. What is the derivative of cosine 2x? The derivative of cosine 2x is negative 2 sine 2x. Negative sine 2x is the derivative of the function cosine 2x, and multiply the derivative of the angle 2x, which equals 2, plus the derivative of tan half x. The derivative of tan half x is sec to the power 2 half x, multiply the derivative of the angle, which equals half. Then in the simplest form, dy dx equals 3 cosine 3x plus 10 sine 2x plus half sec to the power 2 half x. Another example. Find the slope of the tangent to the curve of the function f, where y equals f of x, if y equals 2 cotan x plus square root 2 sec x at x equals pi over 4. We know that the first derivative of the function is the slope of the tangent to the curve of the function at x equals x1. Then, since y equals 2 cotan x plus square root 2 sec x, then dy dx equals the derivative of cotan x equals negative cosec to the power 2x, and the coefficient 2 is a constant. Then the derivative of 2 cotan x is negative 2 cosec to the power 2x, plus square root of 2 is a coefficient of sec x. Then the derivative of sec x equals sec x multiply tan x. Then the derivative of 2 cotan x plus root 2 sec x is negative 2 cosec to the power 2x plus square root 2 multiply sec x tan x. The first derivative is the slope of the tangent to the curve of the function at x equals pi over 4. Then we can substitute about x equals pi over 4. Then dy dx at x equals pi over 4 equals negative 2 cosec to the power 2 pi over 4 plus square root 2 multiply sec pi over 4 multiply tan pi over 4. We can use the calculator. Then dy dx at x equals pi over 4, which is the slope of the tangent to the curve at x equal pi over 4, equals negative 2 multiply cosec power 2 pi over 4, which equals 2, plus square root of 2 times sec pi over 4 equals square root of 2 multiply tan pi over 4, which equals 1. Then dy dx equals at x equal pi over 4 equals negative 2, and the slope of the tangent to the curve is the first derivative of the function, but at x equals x1 or x equal pi over 4 in this example. Another example, if y equals square root of 5 minus 2z and z equals sec 2x, then prove that root 3 multiply the first derivative dy dx plus 12 equal 0 at x equals pi over 6. Now we have y equals square root of 5 minus 2z. Then dy dz equals the derivative of the function inside the root, which is 1 multiply negative 2 over twice the square root over 2 multiply square root of 5 minus 2z. We can cancel 2 from the numerator with 2 from the denominator. Then dy dz equals negative 1 over square root of 5 minus 2z. Now we have z equals sec 2x. Then dz dx equals the derivative of sec 2x equals 2 times sec 2x tan 2x. Now the chain rule dy dx equals dy dz multiply dz dx. Then dy dx equals negative 1 over square root of 5 minus 2z multiply 2 sec 2x tan 2x. And we can write dy dx in the simplest form. dy dx equals negative 2 sec 2x multiply tan 2x over square root of 5 minus 2 sec 2x. Now at x equals pi over 6, then dy dx equals negative 2 sec 2 times pi over 6 tan 2 multiply pi over 6 over square root of 5 minus 2 sec 2 multiply pi over 6. We can use the calculator. Then dy dx equals at x equal pi over 6 equals negative 2 multiply root 3 all over square root of 5 minus 2 times 2 equals negative 4 root 3. Now, what about the left-hand side? The left-hand side equals root 3 dy dx plus 12. Then the left-hand side equals root 3 multiply negative 4 root 3 plus 12, which equals negative 12 plus 12. Then the left-hand side equals 0 equal the right-hand side. Our last example today is if y equal cosec 3x plus 1 over tan 4x minus 1, find dy dx. Now we have y equals quotient of two functions, two trigonometric functions, cosec 3x plus 1 over tan 4x minus 1. What is the first derivative of this function? dy dx equals the derivative of cosec 3x plus 1. Derivative of cosec 3x plus 1 is negative cosec cotan. Negative cosec 3x plus 1 times cotan 3x plus 1 multiply the derivative of the angle. The derivative of 3x plus 1 equals 3. Then the derivative of cosec 3x plus 1 is negative 3 cosec 3x plus 1 multiply cotan 3x plus 1. Multiply tan 4x minus 1, the function in denominator, minus 4 cosec 3x plus 1 multiply sec power 2 4x minus 1. The derivative of the function in denominator, derivative of tan 4x minus 1 equals 4 sec power 2 4x minus 1 multiply cosec 3x plus 1, which is the function in numerator. Then the derivative of cosec 3x plus 1 over tan 4x minus 1 equals negative 3 cosec 3x plus 1 cotan 3x plus 1 multiply tan 4x minus 1. And the second term, negative 4 cosec 3x plus 1 sec power 2 4x minus 1 all over tan between two bracket 4x minus 1 all to the power 2 or tan power 2 4x minus 1. And by this example we come to the end of our program today, and till we meet again, it's goodbye.